Destroying tanks with anti-tank missiles, launching attack drones from safe standoff distances, carrying ammunition, or operating as a node in a multi-domain dispersed combat formation. Just a few things that emerging Army robots will perform in combat. Hello and welcome. I'm Chris Osborne, Center for Military Modernization. Glad you're here. We have a special discussion about robotic technology and the pace at which it's being fast-tracked for future war. There's a program called Robotic Combat Vehicle Medium, and it's a 7 to 10 ton armored vehicle. And one of the people involved in developing this at the highest level is Kevin Mills. He is an Army weapons developer with robotics, and he spoke specifically about some of the tactical advantages it can create when you use robots like this.
So I think one of the unique features of robotic platforms, once you take the human out and they're purposely built to be robotic platforms, they can be much smaller. And still carry significant payloads and have significant mobility characteristics. So the RCV lights, for example, are very hard to detect. And so that right there gives you the operational advantage of being able to push them forward. And it was very hard for the opposing force on the experiment to detect where they were coming from. And they also are hybrid systems, so they can move silently or near silently on all electric mode. So they have that ability, which our current manned forces don't have.
Naturally, while enabling lighter weight maneuver without having to have soldiers inside a vehicle, an armored vehicle can be faster. It can be more maneuverable. It can even, in some cases, potentially be airdroppable. Something like the RCV Medium is being armed with a 30mm cannon, Javelin anti-tank missiles. The Army has been amid a handful of ongoing experiments to place these in the hands of soldiers, assess feedback, refine the requirements, and see what works. There's currently a competition between Kinetic, Textron, and General Dynamics Land Systems. The Army is evaluating 3 different robot possibilities. And General Dynamics Land Systems has emerged with something it calls the T-Rex, which is a modified robot vehicle designed with an obstacle breaching payload, certain weapons configurations, and of course sensors, and perhaps of greatest significance, an ability to launch drones.
The T-Rex, or track robot 10 ton, it's outfitted with an obstacle breaching payload. So again, instead of having engineers in a breach trying to effect a breach of an obstacle where they're being shot at with direct fire or indirect fire from the enemy, I now have a robot doing that job for them.
An ability for a robotic vehicle to launch drones is what can be called unmanned teaming, extremely significant when you have AI-enabled computer systems processing incoming data at the point of collection, organizing and transmitting that data so that humans in a manned vehicle at a safer standoff distance can perform command and control with what's often referred to as a much lower cognitive burden. So you could have, for instance, an armored vehicle testing the perimeter of enemy defenses, even launching attacks, potentially itself launching a small mini drone, which could be an explosive or blanket an area with ISR. The tactical possibilities are astronomical when it comes to these kinds of robotics and how they're anticipated to change future war. In particular, something like AI is paradigm changing because of the speed at which the Army has shown it can truncate or reduce sensor to shooter time. When some people hear or think of this, they think there's a Terminator kind of scenario, and that raises an interesting question. Of course, with Pentagon doctrine, a human must always be in the loop when it comes to the application of lethal force. So the idea is to enable the most maximum amount of autonomy, whether it's semi-autonomy or full autonomy, to perform the highest or widest sphere of potential functions while still relying on those unique attributes fundamental to human cognition to make those crucial decisions. That being said, AI-enabled computers and automation is progressing so quickly that there's actually discussion in a Pentagon essay about something called out of the loop, which is purely for non-lethal or defensive purposes. Perhaps weapons could be enabled by AI to find a target, identify that target, discern which effector, or whether it be a laser or EW or missile of some kind, might be best suited for that particular target. And should it be determined that the target or incoming threat is a mortar, a missile, a drone, not necessarily requiring the use of lethal force, then imagine the speed at which computer processed AI-enabled targeting could find that and take that out. So the two are very much in synergy. All of the most cutting edge thinking at the Pentagon with weapons developers is that optimally there needs to be a blend, high speed computer processing, able to make decisions at exponentially faster paces.
Yeah, it's really a chicken and the egg, because you're giving soldiers a new capability, and the worst thing you could probably do is say, "Hey, fight the exact same way with this new technology." Um, Really, what the press, what AFC is really pushing for us is to give us, get technology in soldiers' hands, let them innovate on the tactics and operations, working hand in hand with the next generation combat vehicle cross-functional team, or NGCV CFT, who is really the warfighter representative in our operational, drives the operational tactics and behaviors that they're keeping really an RCV, or robotic combat vehicle playbook. And that will then inform future doctrine, future CONOPS and TTPs. The sorts of things we used, there were reconnaissance missions, movement to contact, defense, area defense, area attack missions, really the whole playbook for a maneuver mechanized force.
Ultimately, what military developers emphasize is this need to balance or optimize both human cognition along with computer automated systems and AI enabled computing. In this respect, you get the high speed processing and a variety of functions that computers and vehicles can perform autonomously, while at the same time relying upon those unique faculties fundamental to human decision making and human decisions, such as intuition, emotion, things like dynamic decision making. All of these variables are extremely difficult for computers to replicate. Let's say, for instance, an armored column is coming up against a heavily mechanized armored enemy formation. Well, manned tanks might be in position to fire 120 millimeter cannons and rounds to take those out. But perhaps an unmanned system, a robotic vehicle, could position itself forward so that humans and tanks are not subject to enemy fire, to both test the perimeter of these enemy defenses, fire weapons, surveil the actual formations, and transmit information in real time through a collection of networked or meshed nodes of manned-unmanned vehicles to achieve decisive victory over the enemy, or make a strike, make that decision cycle much faster to kill an enemy before you're seen. This is the kind of thing that is already beginning to shape the future of war. These are the kinds of scenarios in which robots will inform the tactical equation and ultimately inspire what's already evolving, which is a more modern conception of combined arms. The idea of something more networked, more multi-domain, AI-enabled, and dispersed across a wider sphere of areas. So robots, while there won't be a Terminator, at least anytime soon, robots firing weapons, robots working in tandem with drones and human decision makers is here to stay. And we're probably going to see more and more of them. Chris Osborne, Warrior Maven, Center for Military Modernization.